All right, this is target 40, where we are looking for all the roots given the equation and using the graph to find them. So in this case, given the polynomial, find the roots. Well, it looks like x cubed, so I know I'm going to have 3 roots. I'm looking for 3 answers. So I'm going to write that down for 3 blanks, and I know I got to find them. The easiest way to find one of them is to punch the equation in your calculator like I have shown here, and then push graph and see what you get. When I push graph, I'm noticing that there's a little bump right here at the bottom, so it bumps up, comes down, and goes back up, and I'm looking for that point right there. To me, it looks like it's at 1, 2, 3, 4. To verify, I can go second table, and I can see next to 4, I have a 0. That tells me that that's one of the roots. I'm looking for a 0, I've found one. So 4 is a root. If I know that 4 is a root, therefore that tells me that x minus 4 is one of the factors. Then if I find the other factor, which is going to be something x squared blah 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 here, because x times x squared makes x to the third, then I know I'm going to be in good shape. And then as soon as I figure out what this is, we always have the quadratic formula available, so I take this answer and I put that in quadratic formula, and quadratic formula will give me the other 2 roots. Now, when I look at this graph that I had before, I can tell right away that those other 2, they are going to be complex roots. I can tell by looking at this graph that I've got this little bump here, and that's going to make it complex. So I know I'm looking for some imaginary number roots, or with i's in them as I go through this. All right, so here we go. We have 2 choices. One is called synthetic division, where you take the root and you put it in the box and you set it up like this, and then you put the 1, the 2, the negative 14, and the negative 40, which are all of the coefficients of each of the numbers in our polynomial. Then I write down my 1, bring it down, and that's the setup. So the amount of setup work it takes is you put the root in the box, you put all of the numbers that are in front of all of the letters here, all of the coefficients, and then you bring the 1 down. And then you just work it out. And you work it out by doing multiplication and addition. So it's multiply, add, multiply, add. 4 times 1 is 4, add, I get 6. 6 times 4 is 24, add, I get 10. 10 times 4 is 40, add, this is my remainder box, and I put a little box around this to remind me that it's my remainder. It better be 0. Then that tells me that this divides in. That leaves me this. This was an x cubed question. Now I just divided it by a factor of x, which drops the power down to an x squared. So this is my equation right here, 1x squared plus 6x plus 10. And that's my other factor that I can then put into quadratic formula. So I go to quadratic formula on my calculator, and I have quad form, so I use that, hit enter, and my a, b, and c are 1, 6, and 10. My coefficients, my a, b, and c for my quadratic formula, and I get negative 3 plus I and negative 3 minus I as my other 2 roots. So negative 3 plus I, negative 3 minus I. Now I also know that the other method to figuring this out is Polynomial, and I do want to show you that here as well. So I'm going to show you the Polynomial method to find the remaining roots. X minus 4 was a factor. So then I go across and I build my generic rectangle just like this, and I put a double line at the bottom telling me what it needs to equal, and it needs to equal this. I'm going to create some workspace here. It needs to equal x cubed plus 2x squared minus 14x minus 40. And I kind of put them over here a little bit because I know that each diagonal has to add to that number. So, and then the last piece of setup is to put the x cubed, which was the first number in the equation, first term, and I put that here in the first box. So this is the setup for Polynomial. Put the answer at the bottom, fill in the first box, put the factor on the side, and then run it through. So what I do is, if I'm going to run this through and solve it, then I know that if this box was x cubed, then this had to be x squared, because x squared times x makes x cubed. If I know that's x squared, multiply here, I'd get negative 4x squared. If that's negative 4x squared, I'm trying to get to 2x squared. So this would have to be 6x squared, because 6 take away 4 is 2. Then if that's 6x squared, then this had to be 6x above there. Multiply there, I get negative 24x. I'm trying to get to negative 14. So this had to be positive 10x. If that was 10x times 10, and x would give me that. And then 10 times negative 4 is negative 40, and we need to get a match right there, and we do. Then I know this is my equation up here, x squared plus 6x plus 10, and that's the Polynomial method to solving that. Now, again, I would like to, I guess, capture this whole idea or concept with the steps that it takes to do this. Step number 1 is graph to find a root. I know I'm going to have one root that's real, maybe 2, and I'm going to use those then as the numbers I can put into my equation. Number 2 is I divide by that root. Divide by the root. Number 3 is I use quadratic formula on my x squared to find other 2 roots. So it's kind of a 3-step process there. Use the graph, and that's what we did originally, and we saw that number 4 come up. Then we used that number 4 as one of the roots, and we did synthetic division to get it down to this, which goes into quadratic formula, which gives me the other 2. Or I could use Polynomial and go through it that way as well. That's the process for finding the roots of a polynomial.